Ice, water, and steam are three forms of matter that have similar kinds of particles. We have often seen how quickly ice changes to water. Ice is solid, water is liquid, and steam is gaseous in nature, which can be seen as fumes coming out from the beaker when it boils. To understand how these particles behave to give rise to different forms of matter, scientists were curious to know how particles of matter surround each other, how do they move, and what sort of interactions do they have with each other. To answer these questions, a lot of scientific experiments were done, based on which we are now able to conclude that particles of matter are very small. They have spaces between each other, they are constantly moving, and that they have forces of attraction between them. Let us validate each individual characteristic of particles of matter. We are quite familiar with the fact that when a potassium permanganate solution is diluted, its color fades, but does not completely go away. From here, we derive the first characteristic of particles of matter, that they are very small. After having discussed that matter consists of extremely small particles, it is time to understand how these particles are arranged. Let us take some water in a beaker and put a spoon in the beaker. We can observe the water level rise with the addition of a spoon. Add some sugar to it and stir it with a spoon. We observe that sugar gets dissolved in it, but the water level does not rise. Let us explain this. When sugar is added to water, the sugar particles occupy the spaces between water particles, as a result of which sugar gets evenly distributed in water, and the level of solution in the beaker does not change. This experiment concludes that particles of matter have spaces between them. However, the size varies from one kind of matter to another. It is worth noting that different kinds of particles have different interparticle spaces between each other. Now let us understand what sort of an interaction the particles of matter experience with each other. To illustrate this, take an iron nail, a piece of wood, and a piece of chalk. Try to break each of them by hammering or crushing. We observe that it is almost impossible to break the iron nail, and it's easiest to break the piece of chalk among the three substances. What does this tell us about? This activity shows that the iron particles are held by the strongest force of attraction, followed by wood, while the particles of chalk have the least forces of attraction between them, which makes it easy to crush a piece of chalk. This not only is easy to understand, but also helps us to explain why we can move our hands in the air freely, but it is not that easy to move our hands in water. It would be almost impossible to move our hands through the wood. Let us perform another activity to understand how particles of matter move. Place an unlit incense stick on the table. Now light it with a matchstick. We observe that within seconds we can smell the incense stick even from a distance once it is lit. We are bound to ask, how does this happen? The answer is that as we light the stick, we increase the temperature of the particles. This in turn increases their kinetic energy, which makes them move quickly and reach our nose. To put it in another way, the particles of the incense stick intermix with the particles of air rapidly and reach us. We now are able to better explain why the smell of hot cooked food reaches us so quickly. This intermixing of particles of one kind through particles of another kind is called diffusion. Since the movement of particles arises on account of kinetic energy, one can conclude that diffusion is governed by temperature. In simple terms, as the temperature increases, the particles gain kinetic energy and break the forces of attraction between them, thereby making diffusion faster. Let us recall what we have learned so far.